All right, thank you. Data-driven valuation as an alternative for a grid. So it's a project of Gudrun Expert. Gudrun Expert is actually a real estate valuation office who works mainly for like the insurance companies and the banks in Belgium. What's the framework? And that's something you have to keep in mind during the presentation. The whole time it goes about residential buildings for private users and only for fire insurance. Otherwise we get some discussions about the business side, and that's not really the goal of tonight. We can do that afterwards, of course. I have an opinion about nearly everything, so okay. What are grids? Well, grids today are used to estimate actually the reinstatement cost of a building. The capital is then used to determine the premium, like Xavier actually mentioned with the motor vehicles. It's actually the same with real estate. And it's also used to see for the insurance company, what's my capital at risk? So how healthy is my insurance? How high do I need to have to set the extra premium and stuff like that? So that's a grid. How does it usually look? Well, actually it's kind of a very easy scoring mechanism. It's actually designed so that everybody can fill it in. And it's mostly based on, let's count something, count the amount of rooms, count some specific elements, how much fireplaces do you have? Do you have an impressive fence around your castle, stuff like that. And then some yes-no questions. Do you have a dog? Do you intend to set your place on fire like 3 times a year? Things like that. And then at the end you have some scoring. You have to count, you have to add some values, and then you have to multiply by some magic number, and then the capital appears. That's always kind of the idea. What's important? Well, the grid is it's always designed for a type of building. It's within a capital range, and there are always exclusions. You cannot use it if you have a swimming pool. You cannot use it if your grandmother is living with you. Stuff like that. Well, what did we do? At some point, well, they asked us, but we decided to go and actually compare the grids with the values we estimated. So we have physical people going actually to the premises, taking all the data and calculating the reinstatement costs. The old-fashioned way with a calculator, really with a calculator in most cases. Some use Excel. And then, well, we actually tried then to benchmark the grids. We anonymized it for now. And what we saw was actually quite frightening. Not for us, but for the insurance companies. Because how do you have to see this? And it's a kind of abuse of notation. I know that, but yeah, it just sets the picture straight. So what you see here is actually the little purple one, is actually the real value. We say that we are right. So what we estimated is the reality. That's something, it's a hypothesis, but we take that for true. Otherwise, I'm standing here talking about nothing. And then we compared some grids that are on the market and where we actually knew how they calculated the capital. And what we saw is that, for instance, here you see the capital. This is 400,000 euros. And we saw that if we take the world, because our database was the world, we saw that about 82% of the world had a capital lower than 400,000 euros. If we then we take the same world, we put it into the grids, just to let them calculate their capital. Then we saw actually that the amount that they saturated, they went to their maximum value much quicker, and that they actually underestimated the value of quite some buildings. Because it's a sample, I think, of 10,000 buildings. So you can see that that in this case, for instance, the most extreme grid, misinterpreted, miscalculated, like 2,000-3,000 buildings, something like that. So that's quite a lot. Also, it's saturated, where you see that the capital is still going on 600, 700, 800,000 euros, and I think we kept at 1 million. You see that there are grids, and almost all grids actually have a saturation point at 500,000 euros, which was not the intention of the people who created the grid. At least they don't mention that on their exclusions. So you never know. So that's actually a problem. We all agree. There's another problem with the grids. It's the scope. It's always for that type of building between those capital ranges, and they're quite narrow in most of the cases. And if you cannot fill in the grid, or it doesn't allow you to fill in the grid to determine the capital, then there's actually only one alternative, and that's the appraisal by an expert. So then actually somebody who knows a lot about real estate comes to your house and determines the value. There are some disadvantages to that. Not for the appraisal office, because they actually live off that, but on an administrative flow, timing, and inconvenience level, there is something you do not like about that. And the one thing, and that's the most difficult thing at this moment, is making the appointment with the customer. Yeah, you want your fire insurance with us, that's no problem. You can wait on a Thursday between 8 a.m. and 5 p.m. And somewhere in that day, if you're lucky, we will appear and estimate the value of your premises. And then the customer is like, yeah, right. You can come at 9:30, and if you're not there at 9:32, then I will be gone. And okay, so that's kind of something like a mentality switch during the last 10 years. You have to visit the premises. Very nice if you have like a fully dressed SM cave and stuff like that, and then there is some kind of expert who's walking around there and saying like, yeah, that adds value. Yeah, I will take that back. So yeah, there's some privacy issues there. Yeah, somebody has to make the report. So that's also very nice, because it takes a lot of time. Not at Gudrun, because that's totally automated, as you will see, but yeah, somebody has to make the report. Somebody has to analyze what the other person has wrote. It has to be put in an IT system. There is some administration that has to be done. Also advantages on an appraisal, yeah, of course. Imagine extreme buildings. I have the Taj Mahal. I've recreated the Taj Mahal in my garden, of course, the little building. And then, try putting that into a model. That's not easy. So, and actually, an appraisal expert will even struggle doing that, but he at least will have the tools to say, okay, yeah, I will just capture the data and afterwards see what I can do with that one. If you have specific or rare uses of buildings, gas stations, houseboats, stuff like that, not easy to model because they're not that common in use. And then, of course, you have the case-specific via the statistics. We all love statistics, and statistics are great, and everybody has a T-shirt with some cool slogan on it. But yeah, if it's case-specific, it's always specific, which has the advantage. Now, what Gudrun actually wanted to do was make a broader scope, be more accurate, be hybrid. Adaptability is important. You saw that with the photovoltaic panels. Like 10 years ago, nobody even heard of them. Nobody, that's kind of, but okay, it was not that common. Today, 50%, 60% of all houses have them. So if you then have a grid on paper, try incorporate the photovoltaic panels. That's not that easy. and with the least possible administrative overhead. So actually what they wanted to do was evolve from a grid into an automatic expertise, model-based, data-driven. And how is it actually made? Well, the data. The data is the most important thing. And there was some visionary work in progress there, because Gruden actually started collecting data as soon as 89 with some barcodes. I don't know, actually, it's like barcodes where they scanned it, and actually every term was in a database, and they never stopped doing that. Okay, they had the same concept, but now they do it on iPad, and they have nice buttons, and it's a whole application. But it always remained the same idea of, okay, let's translate the building into its basic components. Those components, we give some words. They have about 2,500 terms to actually describe a building. Those terms we put all in one big centralized database, and then afterwards we can do everything with that. We can make a new build value, we can estimate the theft, we can look at the value of it on a broad market. Just put in some kind of formula, use the data, and you can estimate the value or other stuff about the real estate. Well, the model, this is actually kind of funny. It was kind of my first bigger project, and I wanted to prove that I really know my shit. I was going to let all the world see how smart I really was. So I took my textbooks, all the stuff I nearly could pronounce, I just blended it all together. I start with some very cool stuff like support vector machines, neural nets, just topped it off with some really fancy things. I cannot even remember what they were. And then we went to the company. We were there, I started explaining, and after like 20 seconds I was like, yeah, very interesting. But yeah, it's not really transparent, we don't get it, we don't want to use it. Is it right? It's not transparent, we're not going to use it. So nice, but redo. And I was like, yeah, how can we do it and make it like easier? And we arrived actually at a simple regression model. And I was kind of embarrassed. I was like, oh no, regression. Little did I know that's like the most popular technique ever. But okay, regression has transparency, and regression is from a business point of view acceptable, because they can really look and like oh, you're counting 500 euros for a square meter. That's nice. And 10,000 euros for a swimming pool. Yeah, that's not that much. Yeah, but the data tells you. Okay, yeah, then we accept it. So, that's really. And if you go there, you say like, this is the neural net. Yeah, that's nice. Yeah. And that's Rosenblatt. Yeah, it's perceptron. And they were like, yeah, very interesting. Okay. What's actually the problem when you're trying to do this one? Well, you need a lot of data. Need a lot of data to be able to model different types of buildings, because in Belgium, in the Netherlands, that's very easy. They have like 5 types of buildings, and then they scale. Yeah, that's actually about right. In Belgium, you have like, you don't have 5 buildings that are exactly the same. So that's kind of the difference. So you need really a lot of data to make this work, and to have something that's valuable, validatable. That's not a word. Valid. That's enough. Okay. So what actually we made, of what was the conclusion at the end of the whole thing? Actually, we have the scope for residential buildings. It's from 65,000 euros. So good luck finding a house for 65,000 euros. Just until 1,750,000 euros. So that's for the poor bastards who can afford that. Everything that is constructed after 1900, from 50 square meters until 800 square meters. So you see it's very broad scope. And standard construction, so no wooden, clay building, stuff like that. That's a whole other model. It's not included here. And actually at the end we had a maximum deviation, no mean deviation, but a maximum deviation of 10% on an independent validation set. So a cross-validation, and that was about it. So we actually managed to do a good job, we thought. How it looks after R&D, yeah. Afterwards, it was transformed into a nice app for an insurance company who's actually using it today. So it's not all theory. Somebody actually uses it. There's a lot of insurance companies are interested in actually using it, but it's still in some kind of NDA, non-disclosure. You cannot mention us phase. So this is how it looks after R&D. So it's a nice. It's created in MathWorks, MATLAB. This one, and you see like all kind of questions with drop boxes. So that was the cool thing. I thought this was very handy and enough. Others wanted an app. I don't get it, but okay, that's a choice. But then the business side was, yeah, but why stop there? Can't you actually generate the policy directly? Like when the broker goes on his internet and he says like, yeah, okay, I'm a broker and I have a client and I want a fire insurance. Okay, just go to the app where actually you can put in automatically all the administrative data is filled in. Give in everything about the real estate. A calculation is made server side. That's for updatability and stuff like that to make it more easy. A publication of the result. Afterwards, the broker gets, or the client actually gets the possibility to say, oh, it's too expensive, or nice, I want it. And then the data file just leaves, goes to the systems of the insurance company, and actually everything is done. The policy is generated, the contract is made. So that's a nice thing, because the new generation, I am the new generation, hip and fancy, as you can see. No, but actually the new generation wants something and wants it now. If I want a new laptop, I want the order at 23:45. I want to push enter, and Sunday morning, the day after, at 9 a.m., I want the laptop at my doorstep. So I'm not going to mention the company who's actually doing that, but yeah, they cost me a lot of money just because they provide that service. So like everything that's impulse, I'm very sensitive to that one. But in insurance, it can be the same thing. I want the fire insurance and I want it now. This system allows that craving. Actually, I thought this was very impressive, but that was the easy part. Then we came at, yeah, just take it into use. I cannot pronounce the word. So take it into use, it's this word. And that's actually the real challenge. Because then you get a whole new play field of ergonomics and color schemas and user management, training, because yeah, you think it's obvious, it's not. How many bedrooms are there? What is a bedroom? It's not that easy. It really isn't. It really isn't easy. What is a bedroom is like a very, very hard question. It's like, okay, I can talk for hours about that one, but so you need some training, you need some manuals, you need some definitions, you need a whole lot more than just your little model that I learned. Very impressive. And then you need some help desk and support. That's also like a major part where you invest a lot of time just to get people to want to use it, because you have the pros, and that's true. You have a broader scope, it's more accurate, you don't have that much administrative overhead. It's adaptable, you can monitor it, you can real-time offer things, there's no intrusion of the client's private life. It all goes faster, it's smoother, toys for boys, everything is true. You have an iPad, you can use it for something useful. But then you have like the cons. You need the will to use it. A broker who has done his job like 30 years on paper and use it and knows the system from front to back and everything about it, now has a new toy, a new tool that he has to use, and it's not that easy to use. It's not that dummy-proof as it's supposed to be. So he will need some training. He will have to learn new definitions. It's quite a fuss. It's not that easy. We as data scientists, computer people, tend to forget that not everybody wants a smartwatch. I have a thing like that, and it's very cool. When my mother looks at it, it's like, oh, it's ugly. Didn't they have that in another color? Yeah, okay, that's not the point. But okay, so it also took development, lots of data, of course. And you have the cost of accuracy, that's to say, you need to ask, with regression, of course, a lot of questions if you want to get to an acceptable or a minimal deviation in this part of 10%. So that are stuff where you can actually improve. Well, that's about it. So if there are any questions, shoot. Yeah, of course.
There is time for questions.
Almost the important part, yeah.
It was very interesting, first I want to say. But I have one important question. So fundamentally, you are predicting the capital.
Yeah.
But what the insurance wants is to predict the premium, they should also the risk. So, I mean, let's say, you say a swimming pool has this amount of value. It's perfectly okay, but it's also a risk element that has to be with the damage or it attracts people who want to steal. Or
True. But actually, Gudrun is a real estate company. Mm-hmm. We do real estate, and we provide the data to structured data where they can work with to the insurance company in this case. And they have to calculate their risk. They know their portfolio much better than we do. They have actuaries, a whole service of them who actually, just laugh when you enter and say like, I know something about risk. Go and play it over there. But because that's their business and they know much more about that than we do. We just made a model that actually facilitates them in getting the right capital for the risk of the capital at risk actually in real estate, and we stop there.
The capital, I think, is just
it's
an intermediate step who doesn't really matter for the insurance. So the fact that they underestimate the capital doesn't mean that they underestimate the premium that they also.
That's true. That's actually true, or it could be true. I don't know actually for sure, but it could be true. But if you can get a better picture. And that's also a very important thing. It's not only the capital that is delivered, it's a report, it's actually a structured data set about a piece of real estate that you're insuring. Mm-hmm. So it's not like afterwards, was there a swimming pool? No, you know, because you have the structured data, digital, not on paper, digital, where you can see, you entered a swimming pool, so everything is fine.
The capital the capital can be seen as a predictive variable along with other variables.
Yeah, you can make whatever you want from it because you have structured data. Actually, the essence is not the capital. It is also a little part, but in the whole risk assessment that an insurance company do, the capital of a real estate is like the tiniest part ever, right? It's like niche, if you want to do a calculation on that one. But it's the structured data about the risk that's really in value, because at one moment, the insurance company who's using this system will be able to tell like, everything with a flat roof. Do we have like the right premium for that one? Or everything with a red front door. Is there a significant bigger risk in fire, in some fire damage or in stuff like that? And actually there is the value. You can actually recalculate everything from the structured data. And now the capital is determined because we are determining capitals like 100 years now, and an insurance company knows that one, but it's the structured data, and also Solvency II is very clear about that. It's transparent, structured data, that's the future. And what we're going to do with it, yeah, we will see in a while when we're ready for that one.